Good afternoon, everyone. Dear authors and invited guests, welcome to Technical Session 8A. Myself, Deepika Jain, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic LLP, it is my great pleasure to welcome you all to the 9th International Conference on Information and Communication Technology for Competitive Strategies ICTCS 2024, Jaipur, India. The ninth edition of the conference has been held in a hybrid mode. The physical event was held in Jaipur, and we are hosting the virtually event on the Zoom platform, that is yesterday and today. I hope you will enjoy the knowledgeable sessions throughout the day. In this session, we have 10 presenters. Each presenters would be getting 8 minutes for their presentation and 2 minutes for any question and answers. On 7 minutes, I'll just raise a gentle reminder, and I request all the participants to stay with us till the end of the session for any of the closing remarks. And if you have any query, you can just contact me directly in the chat box. Just before we start the session, I would like you to introduce to our session chair. Dr. Vinaya Garg. I welcome you, ma'am.
Thank
Dr.
you.
Vinaya Garg is an associate professor at GVM's Gopal Govind Poi Raitukar College of Commerce and Economics, Goa, India. With over 25 years of experience in education, her research interests include digital communication, embedded systems, and error control coding. Dr. Garg has 24 publications in peer-reviewed journals and conference proceedings. I welcome you, ma'am. Thank you for your presence.
Thank you, Deepika, for the brief introduction.
Thank you, ma'am. Okay, so we can start with our first presentation.
Yes,
Just
Anshu Desai, I think first.
Ansh Desai,
Yes, ma'am.
you're going to present a paper on a comprehensive review of machine learning algorithms and their applications in financial market.
Yes, ma'am.
Yes, sir. You
So,
can share your screen, sir.
ma'am, my co-author is also joined, Harsh Kansara. He would
Yeah.
also like to present us as he's a co-author in this.
Yeah, okay.
Yeah.
Problem. You can first start with, you can just share your screen now.
Ma'am, is my screen
So
visible?
you both are going to present the paper, right?
Yes, ma'am.
Yes,
Okay.
ma'am.
Yeah. Okay. You can start, please.
Just a minute, ma'am. Okay. Good afternoon, ma'am. My name is Ansh Desai, and I have authored a review paper on comprehensive review of machine learning algorithms and their financial markets. And so, with me, Harsh Kansara, my co-author, also is there. So we'll start with the table of contents. First would be the introduction to how what would be the presentation would about be. The second would be the core algorithms that are used in financial market predictions, applications and model accuracy of it, challenges and future enhancement, and then we'll conclude with the conclusion. So this presentation provides a comprehensive review of machine learning algorithms and transformation applications financial markets. So basically, in today's world where AI is growing every day, we need some and the reliability should increase in every field of for AI with AI. So in stock market prediction also, AI is being used. Different algorithms of AI are used to improve the accuracy of the prediction of future stocks. So these are the few core algorithms which are used. The first is linear regression, second is decision tree, random forest, support vectors, machines, neural networks, reinforcement learning, and GBM. So the first linear regression is basically used for continuous price prediction task. It predicts continuous values using a linear relationship between input features and the target variable. So it is a simple and interpretable model, and that's why linear regression is used. The decision tree and random forest is used because decision tree segments data hierarchically, and random forest reduces overfitting by combining multiple trees for better predictions. The support vector machines finds optimal high planes for classification, then excels with high dimension data and handles non-linear relationship with kernels. The ANN, the neural networks are subdivided into ANN, LSTM, and CNN. And ANN mimics brain structures to model complex data patterns in general purpose tasks, whereas LSTM captures long-term dependencies in sequential data, which is useful for time series prediction. And the last one, which is CNN, is analyzes partial data, especially effective for image recognition and processing. And this all three are deep learning for complex patterns. They are used for complex patterns only. The fifth one is reinforcement learning. It optimizes actions by learning from rewards and penalties, enabling applications like dynamic portfolio management and autonomous decision making. And the last is GBM, sequential optimization technique, so which builds predictive models sequentially by reducing errors, combining weak learners for high accuracy in regression and classification. These are the main applications, and these are the model accuracy which are been reviewed. So LSTM has the highest accuracy among all, which is 70% to 90% accuracy. The random forest comes second with 80 to 90% accuracy. The logistic regressions comes to 70 to 80% accuracy, and the last is ANN 80 to 95 accuracy. As I mentioned before, ANN model is a sub branch of the complex learning, and it is used in deep learning as well. So ANN model and LSTM models both have high accuracy in financial markets, in the models which are used in financial market. The basic applications of the AI and the machine learning in financial markets are automated trading and risk management. So in automatic trading, it reduces the human error, and it shows us when the stock, it could predict when could stock go high or low, analyzing past performance of a particular uh, company. And the second is risk management. It would forecast potential market loss. It could also predict when and when would the market it could possibly go down for a particular company. So I would like my co-author Harshkan sir to continue with the presentation.
Good afternoon, ma'am. I'll be taking over from this slide. Challenges and future enhancement of AI and machine learning in financial market will go as follow. The complex machine learning models like DNN are often seen as black boxes, making it difficult for the investors and regulators to trust the decisions. So basically, the black boxes occur due to the lack of interpretability, which these models excel at learning intricate patterns in data and making predictions, which is highly opaque. This arises due to high dimensionality, non-linearity, and future interactions. Also, the sudden market shifts or rare events can make models obsolete or inaccurate, which often occurs due to the mood of investors or the economic crisis arises in some country, or there are many other reasons too. Then goes the future directions. So the market sentiment analysis involves the gauging of mood of investors, traders, and general public by analyzing text data from social media platforms like Twitter, news articles or forums, which can be gained through LSTM and SVM. This real-time analysis can provide insight into the collective attitude towards a particular stock or the market trend or the economic event. Uh, Going to the conclusion slide. Uh, so by concluding this PPT, the machine learning is revolutionize the financial forecasting by enabling high accurate data driven prediction. Advanced models such as neural networks and ensembles models uncover complex market patterns while integrating diverse data sources like social media, sentiment, economic indicators, and satellite imagery enhance uh, predictive capabilities. So there are many models which can be used in several ways to collect the data and help us to predict a certain stock or the uh, company, which is basically, yeah, just a sec.
Okay, sir. Thank you for your presentation. Any questions, ma'am?
Yeah, the audience would like to ask any question before me.
Ma'am, if there are any questions from the audience or
Audience,
presenters,
yeah.
they can,
Okay.
put in the chat box.
Yeah.
Any questions, ma'am, from your side, or else we can then.
For how long have you been studying the data? For what period? For the study?
Ma'am, this is basically, am I audible?
Yeah, yeah.
Ma'am, this is basically a review paper based on the various research paper that have been published, in worldwide.
Okay,
So
okay.
we have compressed the data which we got from these research papers.
Okay, okay. Yeah, thank you.
Thank you, sir. Thank you. Okay, so we'll move on to our next presentation. We have Priyal Shah with us, who would be presenting a paper on a holistic disease prediction system with machine learning. Ma'am, you can start sharing your screen.
Yes, ma'am. Am I audible?
Yes, you're audible.
Yes, ma'am. Okay, good afternoon, everyone. It's an honor here to be presenting behalf of my team, that is Dvij Patel, Naman Patel, Shlok Patel, Sachi Joshi, Ved Patel, and Hitesh Makwana, which paper ID is 106. Today we will dive into our project titled A Holistic Disease Prediction System with Machine Learning, an innovation designed to address critical gaps in healthcare diagnostics. So the outline of our presentation is like the introduction, objective, proposed approach, literature review, system implementation, comparison with existing systems, result analysis, limitations and future work, conclusion and references. So, healthcare today is increasingly data driven, and with advancements in technology, there is an immense opportunity to use machine learning for disease prediction and early detection. However, most of the current systems are focused on single disease, that is like diabetes, heart conditions, brain tumors, or pneumonia, leaving patients and doctors juggling multiple platforms. So we asked ourselves a simple but powerful question, that is, why not create a system that unifies these predictions into one efficient platform? So our mission wasn't just to create another prediction tool, but we aimed to develop a reliable, comprehensive system that could predict multiple diseases simultaneously. This would not only save time, but also make early interventions easier and more accessible for patients and healthcare providers alike. So our objective was to develop a unified and reliable multi-disease prediction system which simultaneously predicts multiple diseases using different machine learning algorithms and reduces the dependency on multiple platforms for disease-specific diagnostics. So in our project, there is 4 diseases which are being identified, that is diabetes, heart conditions, brain tumors and pneumonia. And we have integrated multiple data sets representing diseases like diabetes, heart conditions, brain tumors, and pneumonia using advanced machine learning algorithms like support vector machine, logistic regression, and random forest, which ensured high accuracy across predictions. To make it accessible, we built a user-friendly interface powered by Django, enabling real-time prediction at the click of a button. Like it is a single tool which is capable of providing insights into a patient's risk for multiple illnesses, thereby simplifying healthcare decisions dramatically. So these are few snapshots of our system. This is our home page, which provides a basic overview of the system and uh, information about the specific diseases. This is then classification of what type of pneumonia and diabetes are there. Uh, for brain tumor and pneumonia, we have used image classification, and for diabetes and heart disease, we have used numerical data. So after providing the data, it provides us graphical representation as well as the tabular data in which our disease is being diagnosed. These are few literature review which we have done before implementing our models. So comparison with existing system. The existing system just focused on single disease predictions, requiring using to rely on multiple platforms. But our proposed system combines multiple disease models into one, eliminating platform switching and reducing misdiagnosis. So in existing systems, they were disease specific. They were providing accuracy up to 97%, and they were limited to specific conditions, and they were minimally interoperable. But in our proposed system, they provide us multi-disease prediction up to 99% accuracy and unified interface for all the predictions. And we have used multiple algorithms. We have tried multiple algorithms on all the disease and just selected the algorithm which provides the best accuracy, and it is flexible for additional usage also. So result analysis. For brain tumor prediction, our model provides 99% accuracy, and in which we have used CNN using transfer learning. For heart disease prediction, we have 92% accuracy, and the algorithm we have used is logistic regression. For diabetes prediction, we have 98.75% accuracy, and the algorithm is decision trees. Whereas for pneumonia prediction, the accuracy is 97%, and we have used ensemble machine learning models. So this is the tabular format in which the models and the matrices, that is accuracy, precision, recall, and F1 score is provided. And our system performs best for brain tumor detection. So limitations, we have to depend on high quality pre-processed data sets. But of course, the journey wasn't without challenges. We faced hurdles like imbalanced data sets and the complexity of integrating multiple disease models. But we have kept that in our mind, and we will integrate that in our future work. So we would also integrate additional diseases and risk factors into our prediction model. We can also use explainable AI for better model interpretability, incorporate real-time monitoring using IoT devices and electronic medical records, and expand our user interface for mobile and voice-enabled accessibility. So, in conclusion, this project is a step toward creating a seamless healthcare experience. It's not just about diagnosing diseases, but about empowering patients and practitioners with better tools for better outcomes. Uh, this is from our side, and these are few references which we have used. If you have any questions, you may ask. Thank you.
Priya, it's a very good study that you have done.
Thank you, ma'am.
I had one question is, have you, this is, you have tried only from the databases, the data?
Sorry, ma'am. Can you please
The
repeat?
data sets, they are secondary data, right?
Yes, ma'am. We
Have you
have
tried, have you tried with the primary data using some sensors or something?
no, ma'am, we have just trained our machine learning models and we have used the data which were available from Kaggle or some data set, as well as we have used some X-rays from real time, and we have kept in our model, and it also provides us better accuracy.
So which are this machine learning models for the image processing which are best working as per your performance result analysis?
Yes, ma'am. For image dataset, there are two diseases which we have used, that is pneumonia and brain tumor. And for brain tumor, we have used CNN model, whereas for pneumonia prediction, we have used ensemble learning models.
But why there's different models are used? Can CNN be used for both the things?
Yes, ma'am. We have tried all the models for all the diseases, but the model which we have used specifically, it provides better accuracy and better performance.
Okay. Thank you.
Thank you,
Thank
ma'am.
you. Thank you, Priyal. Thank you, ma'am.
Thank you.
Thank you. Okay, so we move to our next presentation. We have our next presenter with us who will be presenting a paper on advanced integration of fuzzy MTM, LSTM, and MLP models for forecasting stock prices. Sir?
Yeah, sure. Let me share the screen.
Yes, sir. Yes, please. Yes, sir. I can see your screen.
Yeah, sure. Thank you. Good afternoon, everyone. I'm Levi from Ho Chi Minh City, Vietnam. And first of all, I would like to thank you for the opportunity to present my work today. My presentation will focus on paper ID 116, advanced integration of fuzzy many-to-many long short-term memory and multi-layer perceptron layers models for forecasting stock prices. My presentation consists of 4 sections. I will I will move to the first one. First, we will discuss about the paper motivation. We know optimizing stock portfolios continues to be a critical focus in financial sector, and achieving optimal returns heavily depends on accurately forecasting stock prices, as understanding price trends plays a significant role in enhancing investment outcomes. So in this presentation, I will introduce a system developed to assist investors in prediction stock prices. This is particularly important in markets like Vietnam, where individual investors dominate and accounting for 99.2% of stock trading accounts. And interesting, the proposed model demonstrates outstanding performance, delivering predictions that are very close to actual prices. Next, I will detail about the proposed system. We utilize fuzzy logic in combination with a many-to-many long short-term memory and a multi-layer perceptron layer network to forecast stock prices. It consists of 5 components. First is the database where we store stock closing price. Next component is data preparation. Next is the fuzzification. Then equal to fuzzy supervised weight adjustment. And here is the main component that really predict the prices and how system will show the absolute predicted prices. To be continued, I will detail each component. This one, the first one is data preparation, which consists of three features. First, we perform feature engineering to calculate different stock prices chronologically and normalize them. Then we perform feature selection using mutual information regression. Then we chose the top features based on these important scores. Lastly, we perform clustering using density-based partial clustering of application with noise to cluster the data. And the next one is the falsification component. Basically, this component converts data into fuzzy sets by calculating membership values based on cluster labels. And we use Gaussian function in this module. The next one is the supervised weight adjustments. By utilizing the pseudo weights, the model begins with a more accurate approximation of the underlying data distribution, which can result in faster convergence during training or improve overall performance. Initializing the long short-term memory layer with the pseudo weights allows the model to utilize prior learning or domain-specific knowledge embedded in the weights. This can steer the model during the training phase, potentially reducing the number of training epochs required and enhancing the model ability to generalize the data from the data. About the mathematical formulation here, but due to the time constraints, for more information, please refer to the paper. Yeah. Next, this is the final component and also the main component, which really do the prediction, and it consists of six layers. The first one is the input layer, which takes input formatted according to the input shape specified by the previous component, and then it comes to many long short-term memory. With each long short-term memory layer outputs a full sequence rather than just the last element. And next one is the dropout. We added here to prevent overfitting by randomly setting a fraction of input units to zero at each update during training. And the next is the time distributed layer. This layer applies a dense layer to each time step of the long short-term memory outputs, enabling many-to-many prediction. Then it's come to the multi-layer perceptron layers. And the final is the fuzzy consequent output layer, a dense layer with a linear activation function to produce the fuzzy consequent prediction. So in here, fuzzy logic is incorporated into the model's predictions by calculating fuzzy consequence and adjusting the output based on fuzzy rules. The rule base is updated dynamically during training with a forecasting factor gradually reducing the influence of outer rules. Unlike traditional fuzzy system with explicitly defined rules, our module dynamically generates and updates rules based on cluster and training data. So the rules in our system are adaptive and data-driven, evolving as the model learns, providing flexibility and continuous learning, which contrasts with the rigid structure and redefined fuzzy logic system. Next, I will move to the implementation results. So in this paper, we collect the data from the Vietnam Stock Exchange from the beginning of 2009 to the end of 2023, and the data from 2023 result for testing, the other for training. And after verify the data, we have the 93 stocks. Yeah. About the parameter, please refer to the paper for more information. I will go directly to the results. So you can see that in this cup, we perform the segment look head forecasting, right? So, and about the the performance, you can see that the robust model demonstrate outstanding performance, delivering the prediction that are very close to actual values as indicated by the low error metric here. Yeah, you can see that MEA just 1.2 in the scope of this paper, just K Vietnam đồng. Yeah, so not much. And The strong elsewhere value further confirms that the model effectively captures data variability, making it highly reliable for predictions. Yep. Here is the visualization of the table previously. Yeah. And the next, and also the last one is visualize for a prediction for the KBC stock. The red line is the predicted prices, and the pink is the actual prices. Yeah. In
Dear
conclusion,
presenter, you have 2 minutes.
yeah, that's it. This is the last slide. Yeah. So in conclusion, we have introduced a system and evaluated it using the Vietnam stock data. Our primary objective was to forecast stock prices and the via experimental results. We have demonstrated that it provides high accuracy, lower error matrix, and model effectively captures data variability. So in future research, we could expand the data set, incorporating advanced feature engineering techniques, for example, technical indicators. Finally, we can consider adding attention mechanism into the long short-term memory layers to help the model have a better prediction. Yeah. Yeah, that's it. Thank you for your attention. Yeah.
Thank you, sir. Thank you for your presentation. Any questions, ma'am?
Yeah, please go to the second last slide, the prediction slide. Yeah. So the actual prices, if you see, there is a difference, no? Predicted and actual prices.
Yeah.
What's the
It,
reason for that? Yeah.
so in this one, we try to predict a segment ahead. Here is the beginning, and the red line is the predicted prices. The pink is the actual prices. This is the beginning. Yeah, and then come
So
to the
have you
first.
tried to analyze why there is so much of difference?
So much difference. Oh, I don't think this is so much difference, because in Vietnam, 1,000 Vietnam đồng is not much. Yeah.
Okay. Yeah, thank you.
Thank you, sir. Thank you for your presentation.
Yeah, thank you.
So we have our next presenter with us, Tripti Sharma, who would be presenting a paper on common couple fixed point findings for weakly compatible maps of integral type in S-metric spaces. Yes, ma'am, you can start sharing your screen.
Screen is visible, ma'am?
Yeah.
Okay, ma'am. Good afternoon, all of you. Myself, Tripti Sharma. Today, I am going to represent my paper on the topic Common Coupled Fixed Point Findings for Occasionally Weakly Compatible Maps of Integral Type in
Tripti,
Asymmetric.
there's some disturbance in the voice. You can just fix it. Some mic problem maybe. You can just try again speaking.
Okay.
Yeah.
My topic is Common Coupled Fixed Point Findings for Occasionally Weakly Compatible Maps of Integral Type in S-metric spaces using CLRG property. Abstract of my paper is this study aims to show certain common coupled fixed point findings for occasionally weakly compatible maps of integral type and for CLRG property with setup of S-metric spaces. We also provide an illustration to spot the outcomes. The findings in this research expand upon, enhance and generalize a number of earlier studies from the body of literature. Now the introduction. Banach established a theorem in 1922 that guaranteed the existence and uniqueness of fixed point under certain circumstances. In 1984, Deng extended the concept of metric spaces by introducing D-metric spaces, whereas J. Mustafa and B. Sims introduced the alternatively more refined generalization known as G-metric space to overcome fundamental flaws in B.C. Dang's theory. By altering D-metric and G-metric spaces, Sergey established several fixed point theorems and presented the idea of S-metric space. In Bhaskar and Lakshmi Kantam established the idea of coupled fixed points and demonstrated a few related findings in partially ordered metrical setup. Serik and Lakshmi Kantam then expanded these findings to include coupled coincidence and CCFP results for non-linear contraction in partially ordered metrical setup. Then Zhang investigated the common coupled fixed point problems, that is known as CFP problem, in case when two maps commute or compatible. In 1998, Zhang and Rodas proposed the concept of weakly compatibility. Elementary interpretations, these are the definition. First is for the set H and HLTO belongs to H, a map S H cube to 0 to infinity is considered as a S metric on H if SHLT is greater than equal to 0, SHLT equal to 0 if and only if all the points are equal, SHLT is less than equal to SHH0 plus SLL0 plus STT0. Then this pair is known as SMS, means S-metric space. This is the definition for contraction. For SMS, a map FH to H is a contraction if there exists a point L between 0 to 1 with the condition SFH FL FT is less than equal to LS HLT. For the function AB H to H, a point T belongs to H is termed as fixed point of operator if AT equal to T. CFP coupled fixed point of A and B if AT equal to BT equal to T. The point mu is referred to as a coincident point of A and B, and T is referred to as a point of coincidence of A and B if T equal to A nu equal to B nu for nu belongs to H. Next, for T belongs to H, the map A and B are considered to be commuting if ABT equal to BAT. An element HL, H cross to H is termed as CFP, common fixed point, if AH cross H to H, if AHL equal to H equal to A and ALH equal to L. Second point, coupled coincidence point means CCP if AH cross H to H and BH to H if AHL equal to BH and ALH equal to BL. And CCFP, common coupled fixed point if AH cross H to H and BH to H if H equal to AHL equal to BH and L equal to ALH equal to BL. The sequence is known as convergent if there exists T belongs to H with HP to T converges to 0 as P tends to infinity. We can write this as limit P tends to infinity HP equal to T. Next definition is the sequence HP in H is Cauchy if and only if SHP, HP, HM converges to 0 as P, T and M converges to infinity. Now next is CLRG property. The map A H cross H to H and B H cross H to H is considered to satisfy CLRG property, common limit range property, if there exists the sequence mu P and nu P in H with the condition limit P tends to infinity A mu P equal to limit P tends to infinity B nu P equal to B nu, limit P tends to infinity A nu P equal to limit P tends to infinity B nu P equal to B nu. With these definition, I will come on my result. This is the result. The definition, the theorem of my paper of our paper is: we consider HS as a complete SMS S metric space. Let A H cross H to H and B H cross H to H be two maps meeting the following requirements for HL mu nu T X belongs to H. Whenever it satisfies these equation number 2, this equation number 2, where O1, O2, O3, O4, O5 are non-negative constants with the condition O1 plus O2 plus O5 is less than 1. AB is OWS, occasionally weakly compatible. AB fulfills CLRG property. Then we have proved this A and B has its own CCP, common coupled point. Additionally, there exists a single point H belongs to H, for which H equal to AHH equal to BH. This is the proof of my theorem, of our theorem, by using the CLRG property. We have proved the theorem. To support our theorem, we have provided example also. Let h equal to 0 to 1 and s h cube to 0 to infinity be defined as s h l t equal to mod of l minus t plus mod of l plus t minus 2h. For h l t to h, it is clear that hs is a asymmetric space. Describe the map A h cross h to h and B h to h as it satisfy AHL equal to whenever HL comes from 0 to 0 0.5, 0 0.04, H plus L is the value. If HL comes from comes from the interval 0 0.5 to 1, the value is 0 0.25. For HL belongs to H and BH is equal to H by 5 whenever H comes from 0 to 0 0.5 and 0 if 0 belongs to 0 0.5 to 1 for H belongs to H. This is the proof of example. By taking these cases, case 1, 2 and 3, we have proved the theorem. These are references. Yes, ma'am. Thank you.
Thank you for your presentation. Ma'am, any questions?
Yeah, Tripti. This is, I think, mostly a mathematical study.
Yes, ma'am.
I just wanted to know what are the applications of this study?
This is an integral application.
Yes.
This is an integral equation, ma'am. I have proved my result in integral to solve the integral equation.
Yeah. So can you, what are the areas, which are the areas where you can apply this type of study?
In fuzzy environment, ma'am.
Okay.
In integral. Yes, ma'am.
Okay. Thank you.
Okay, ma'am. Thank you.
Thank you. Thank you. So we have our next presenter. Kishan, who would be presenting a paper on intelligent lane tracking autonomous vehicle. Yes, Kishan, you can start sharing your screen now.
Good afternoon, ma'am. Thank you for this opportunity. So we will be sharing our research on information and communication technologies for competitive strategies for this platform. So our problem statement is intelligent lane tracking of autonomous vehicle. So our plan is to develop a system that accurately detects, safely navigate, and effectively. So why do we need this? Because as we have seen in very hilly areas and other areas where fog and smog is a lot, the roads are not completely visible. They are only visible up to 2 to 3 meters. So if this setup is installed in various computers and various autonomous vehicles and various trucks and tractors, so we could reduce the accidents by a lot because human life is human life. No matter whether it is a layman or a prime minister, a life is a life. So we are planning to diverse this into various vehicles. And we have also installed this software on the vehicle and we have already run it and it was running very smoothly. So why we are running this is accuracy and reliability. The system will detect the lane boundaries and changes in other relevant features in various environments like urbans, highways, and weather conditions, sunny rays, as I said. Also the fog and smog, that is the mixture of pollution and very cold temperatures to ensure safe navigation. And second one is real-time processing because we need very fast and very quick processing that makes it more safer and more real-time. Safety compliance, meeting safety standards such as ISO 26262 and ensuring reliability under different scenarios. Safety and integration and compatibility, seamless integration with existing vehicles that are already running because so that we don't need a newer infrastructure. We should be using this on currently running vehicles because already vehicles are so much. So we plan on running this software on various vehicles, just using a camera, a processor, and a real-time data output. So data requirements and continuous learning also because this data will be uploaded in real time because whenever there is a congestion, various vehicles cannot see what is there in front of them other than a truck. So uh, with this, we can also use the real-time data that outputs the data effectively to all the vehicles running behind it. So next is the application in societal context, that is enhanced road safety, improved traffic flow. This also gives us a better mileage and also accessibility. Even if we are sleepy or the driver is sleepy, we cannot be reliant on them because even if so many people are under pressure and so many people are traveling with their families, they cannot switch because sometimes there is only a single driver or other who cannot drive. Environmental benefits and urban planning and infrastructure, it will make that picture more smoother. Uh, these are the people that we referred, and we also took the guidance of our guide, that is Rohit sir, who has been working on this system for more than 3 to 4 years. He has a lot of knowledge about this, and we are also working on this from past 3 semesters. So we think that he has better knowledge and better expertise on this. So we asked him. These are the 4 papers that were suggested by him. So we discussed this, and we pluck out some algorithms and some technologies from these only. So the next one is best suited solution is like region of interest using advanced edge detection systems and hue transform to enhance accuracy. What this does is it will detect the yellow line and the yellow markings. It will make pixels as a points and it will take a median. And that median should have to reside with the centroid of the line that we have already given. So it will detect the lane and it will run on that lane only. This is very important because it's not the region of interest is dependent because very important because it should not detect the other lines markings. So next one is these are our inputs, outputs, and input specifications and output specifications. That is video stream, simulated data, and output is lane markings. It will detect lane curvature. It will detect. It will also detect lane departure, and also it will control vehicle commands. That is steering, how much steering at how much angle at how much speed. And these are the input specifications. We have used RGB transformation at 120 FPS. That is 820 to 410 pixels. And the color space is RGB, red, green, and blue. The color space is used also a conversion into other color spaces like HSV, that is hue, saturation, and value. Because we are going to detect yellow, uh, it should not detect yellow light falling on white light. So we have reduced the range so that it does only detect the lemon yellow that is on the center of the lane. So and output specifications I'll be telling you further. This is the functional block diagram. Video will be streamed. There will be a pre-processing definition defining the ROI, that is region of interest. It will mask that yellow. It will detect shown as red color, and it will start detecting the edges. Then it will show what is the lane detection using blue transform and the output that is the detected lane markings. So this is the functional block diagram, that is image acquisition method and pre-processing module, lane detection module. In pre-processing module, it will detect yellow lines. In lane detection model, it will detect where the lane is. Control module is steering command controls, and feedback loop is a PID controller. Like you have to bring it back whether if it deviates slightly, you have to bring it back. And performance evaluation model that will tell us the accuracy in the end. that how much it detected the yellow line and how many times it did not. So right now our efficiency is 99.6%. The rest of 0.4% is due to slightly reflection of the sun on that white plane that we have. These are the details. This is also the preparation, implementation, and testing and evaluation that I've already shared with you. Now this is the algorithmic optimization that is efficient edge detection to transform ROI. Similarly, hardware also I've told you data optimization. We have reduced the data because we have only directly put the software into that NVIDIA Jetson TXT board that is there in our car. So this is our MATLAB model, and we also all of this is detecting the data, detecting the output, and detecting the speed. And these are the blocks inside the Simulink. That is linear polyfit FCN lane mask. Lane mask is used to detect the yellow line. From the yellow line, it will convert it to red dots, and that pixels will be converted into centroid, and that median should have to coincide with the marking that we have done. And it will calculate distance also, calculate speed also. So these are the HSP values of the MATLAB code, and these are the values that we have set. That is 1 to 65. Saturation is 55 to 195. Value of minimum and maximum is 60 to 185. This is the region of interest value, and apart from that, this is our video. I'm only showing you right now. Yeah. So it will be detecting the yellow line, and with respect to yellow line, it will be on the right side of the lane.
Dear presenter, you need to just conclude now. You can conclude,
Yeah,
please.
just a second. This is the lane marking. This is showing the lane markings here. Right? This is the real-time data that is being given from the car to our computer using Wi-Fi. Thank you. So this was us from Delhi Technological University, Naman, Kishan, Yashodhar, and Nishant. We are going to conclude this by saying that this will be very, very, very viable and very efficient in high-speed rails and high-speed like road trains and like in US. And also it will reduce the congestion and it will improve the traffic flow. Thank you.
Thank you.
Thank you for the opportunity. I see.
Thank you, Kishan. It was a very interesting project.
Any question?
And yeah, very interesting
Naman,
project and presentation also. Only
Thank
one
you, ma'am.
question I have is how come you have selected this algorithm only? Why not any other algorithm?
Because this was running very
Hello?
efficiently on our the chip that we have, that is NVIDIA Jetson TX2 board. In this Q car, it runs automatically on all the algorithms that we provide. So by our and all, although the first initial part that is making the blocks and all was very challenging and very demanding, it took around 2 to 3 months to do that only. So, but we saw that after it is done, it is working very efficiently. And this is what we were doing, because this is we have also done lane detection in the first year also, but it was just detecting here, only detecting that it was like line follower. It was not so serious. But this time we have
Are there any other algorithms?
other algorithms are there, ma'am, but they are not that efficient because
What are the names? You know the names of any other algorithms for this
like
application?
no algorithms in the sense they're just different types of filters.
Okay.
But what the problem, because in our lab that we have, there is a map. So it was detecting the yellow light from the map. So we had to reduce our HSP values. We have to put other filters and all. That is U transform and all.
So it is not following any algorithm. It's only based on the filters, is it?
Filters and that block.
Because it's using edge detection algorithm. And
HSP values block and
yeah.
This is like algorithm is like just a name that is to make others understand better. It was it was like it is detecting the pixels on which yellow is shown, and from that pixel it is taking 100 and 200 points.
Okay.
Respectively, how many points are there, and from that points, it is making a one median that is
Okay.
passing through almost all the points, like all
Fine, understood. Yeah. Thank you. Yeah.
around and on. And
Thank
that
you.
average, it is taking the centroid, and that centroid is like converging that with what
Yeah.
values we have given.
Thank you.
Whether we want to be on the right side of the lane or left side of the lane, we can change it.
Okay, thank you. Yeah.
Thank you,
Thank
Naman.
you.
Thank you, Kishan.
Thank you.
We have our next presenter with us, Sindhu Madhuri, who would be presenting a paper on deciphering job trends, LinkedIn data analysis perspective.
Yeah, I'm sharing my screen.
Yes, please. Yes, ma'am, you can start.
Yeah, good afternoon, everyone. Thank you for the opportunity for letting us present. I am Sandhya Madhuri from Chaitanya Bharati Institute of Technology, Hyderabad, and I'm here to present my paper, Deciphering Job Trends, a LinkedIn Data Analysis Perspective. So in this presentation, I'll tell you about the introduction, the literature survey, and our data set curation and the analysis tasks that we have performed using the data set. So first, let's start with the introduction. The main aim of our project was to focus on LinkedIn. We have the job market is complex and constantly changing with millions of job postings on LinkedIn, right? So our project, LinkedIn Insights, aims to analyze the job postings that are posted on LinkedIn and analyze the job posts posted for that year. So we have curated a data set. So before going to dataset, I'll tell you about the literature review. So we have conducted our literature review on like 12 papers, and I have mentioned 3 base papers that we have reviewed. So first is the web scraping of LinkedIn, where the authors have curated a data from LinkedIn by web scraping using Beautiful Soup, but they have not performed any analysis task on the dataset. And next is the paper where the authors have used the LinkedIn data and performed few analysis tasks, and they have found out few results using a random forest classifier. The limitations of this paper was that there is an inconsistency in the data level. And next is the emerging trends in the data analytics and knowledge management job market, where they have used an KSA framework. And this paper hasn't provided on how there is a relationship between the job experience and the KSA levels. And coming to the data sets that we have used, that we have researched, we have found out 2 base data sets. One is LinkedIn Job USA data set taken from Kaggle, which has like 43,000 rows and which have 9 attributes. But the data has focused only on the data analysis roles only for Africa, Canada, and USA. And another data set was industry mapping data set that we have found in Kaggle. The data set only deals with the industries and not with the job titles. So from this, we have decided to curate our own data set, which consists of 9 attributes. And we have curated our data set using LinkedIn by using an automation tool called Octopus, which is a scraping tool. From LinkedIn, we have scraped our data set with 9 attributes, as you can see here. Job title, company name, location, hiring status, date, seniority level, job functions, employment type, and industry. So we have curated the data set, which consists of around 30,000 plus rows and these 9 attributes. And we have performed analysis tasks using this data set, which we have also published in Kaggle. These are the list of analysis tasks that we have done on our data set, as you can see here. Now I will explain you in detail about these analysis tasks that we have performed on our data set. So first, before performing this analysis task, we have cleaned our data set by replacing the missing values with NA, and we have shuffled the data set because while scraping, we scraped according to a job titles. So all the job titles were in the data set are in the same order. So we shuffled the data set for better results. And in the location, we have separated the city and country. And coming to the algorithms and techniques that we have used, the first one is I will tell you by explaining each analysis task. The first is exploring the distribution of job titles across companies. So this analysis is basically a bar chart. So as you can see here in the graph, so here these are the companies and here these are the counts. So as you can see here, let's take diverse links is a company which have here using the index, you can see the job titles. Here you can see which is pink color, which is AWS Cloud Engineer. So this company has posted the job titles AWS Cloud Engineer up to 10. So that up to 5 in a month. So that is how we have made this bar chart. So you can understand that which company is posting which job title on what on how frequently. So this will help the users to understand that which company posts which job titles more frequently. And next is the geographic analysis of job titles, which we have done using chloropeth maps. So here, as you can see in the graph, this is the job count and these are the country. So as you can see in few areas, the job counts are really low. We have not specifically mentioned about the job titles and in the graph, but we have mentioned it in our paper. So in the PPT, we have not presented it. And next is the predicting job locations for job titles. Here, just we have put the output. So for this, we have used logistic regression to predict the locations for job titles. So here in this model, what will it do is if you enter the job title, for example, data scientist, it will predict the job location, like the most possible job location for that job title, which is Karnataka, India. So the most job titles posted in that area. So this is how it works. The next analysis task will be told by my co-author Tanmay. Tanmay, you can continue.
As we see here, we are using QML models and we're using K-fold cross-validation method to evaluate what each model's efficiency or accuracy is. So we see K-fold cross-validation model uses robust methods, uh, reducing overfitting and testing the models on the subsets of the data. It also provides insights into the efficiency of each model for this, particularly for predicting locations. So here we've used performance metrics as accuracy, and as we see the inferred statement in the below, we see random forest and decision tree algorithms both have 0.5 accuracy, which is 50% of accuracy in predicting appropriate job title locations. So this is a different analysis task which we are doing on two of the attributes in our data set. We're using job title field and the date field to predict what job titles are posted in which month they're posted more. So for this visualization, we used heat maps, where heat maps shows us the count, and they help us see like XY in the XY field, which job posts are posted most in the month. So in the next one, we see job titles classification by date. So this analysis task tracks job market changes over time by analyzing job title frequencies. It also provides insights into model performance and feature effectiveness, which helps business in staying competitive. This we have implemented after performing NLP tasks, and we've used different models, which is naive classifier, random forest, decision tree, and support vector machine. So each model has its own uh, uh, profits, where we can see like naive classifier is helpful for heavy text attributes, logistic regression. We also see a decision tree is helpful for interpretable and nonlinear data sets. We see random forest, it boosts accuracy
Dear
and prevents.
presenter, you just have 2 minutes.
Okay, we'll continue with the next thing. evaluation of ML models for predicting employment types. Similarly, we've used all these models. Sindhu, you can just go to the next one. So again here for comparing machine learning algorithms for classifying job postings, we've used two models which are very effective after certain analysis, which is multinomial name-based classifier and SVM. And as we can see, support vector machine is very helpful in classifying the job postings by giving 76% accuracy. And also there is another analysis task, which is analysis of employment types by seniority level. It identifies patterns in the distribution of employment types. So here we've used chi-square test, and for that we can see the contingency table. And next, if we see so by this, we conclude that we have curated our own data set and pre-processed and cleaned the data, as the scraped data has more number of duplicates and inconsistencies. We've used multiple ML models and multiple methods in Python to do few analysis tasks on each of the attribute we curated in the data set. And also our study has few gaps, which is the curated data set is not a real-time data. We've limited the data to a particular time period. So the insights which we just saw were all in the past. We cannot do a real-time analysis. For this, we need more data. And also as we can see the model's accuracy, we need to fine-tune the models with using more data. We've curated only limited data, and we can also use more number of NLP models for further investigating the trends between each field in the job market by using this data set. Thank you.
Thank you for your presentation.
Hello.
Any question?
Yeah, can you go to slide number 14? So evaluation of ML models for predicting employment type on basis of job titles. So can you explain this significance of these values? 50% for decision tree, random forest.
So yeah, basically the analysis task here is that we are on the basis of job titles, we are predicting the employment type. So let's say we have a job title of software engineer posted by a particular company. Here we are predicting the employment type that it is going to offer by the company, like internship, full time or part time or contract basis. So for that we have used four models: multi-nominal naive Bayes, logistic regression, decision tree, and random forest, which
Okay,
on which
so if it is giving just 50% accuracy, that means the job titles, employment type, you cannot, it will may not be based on
yes,
the
ma'am.
job titles. Is that so? Yeah.
Yes, ma'am. So
Okay.
we are showing that the significance is not much more
Not
between
much.
employment time and job titles. Yeah.
Okay. Yeah. Thank you. Yeah.
Thank you, ma'am.
Thank you, Madhuri. Thank you.
Thank you.
Thank you, Tanmay. Okay, so we have a next presenter with us. Do we have Uma, Gaurav here, or anyone who is going to present the paper on her behalf? Any other
Yes, ma'am.
presenter?
Yes, ma'am.
The name, sir?
Rajvardhan Nalode.
Rajvardhan, right?
Yes.
Okay. We're going to present a paper on deep fake detection, integration of inception, net and RESTnet multitask cascaded convolution networks.
Yes, ma'am. Thank you.
Any other speakers with you, sir, who's going to, speak or something? Or is it you who's going?
Yes, ma'am. We have a team of 4.
So are you all together presenting?
Yes.
Okay, sir. Please share your screen.
I'll share my screen now.
Yes.
So good afternoon, everyone. Thank you for this opportunity. Today, we present a research initiative addressing one of the most pressing challenges in AI, that is defect detection. Our paper titled Defect Detection, Integration of Inception, ResNet and MTCNN, identified with paper ID 67. This research is a collaborative effort conducted at our college by me, Bhanuda Segaje, Bhargav Maiskar, and Prerna Patil. With my team today, I am excited to walk you through our findings and innovations, which integrate state-of-art technologies like Inception, ResNet, and MTCN. Next slide, please. Okay, so as you can see on the slide, the presentation will cover the following topics. So let us begin with the problem statement. Deepfakes are highly realistic media generated using AI, pose significant threats to individual privacy, national security, and ethics. By enabling hyper-realistic face swapping, deepfakes are challenging to identify and distinguish from authentic content. This manipulation capability presents a serious problem. Like, it enables misinformation and false narrative to spread rapidly. It raises concerns about privacy violations and online fraud. Also, it highlights the gap in current technological solutions that fail to provide reliable and real-time detection systems. Our challenge is to develop a robust defect detection system that can distinguish between authentic and manipulated content while adapting to evolving threats. This research aims to address precisely that. So my teammate Abhishek will provide further insights.
So next point is objective. The first research focus of this research is to develop a robust defect detection system using advanced computer vision and deep learning techniques. The objective aims to address key challenges related to spread of misinformation and improve detection capabilities. The first objective is fraudulent content identification. To create a system that can accurately identify manipulated image, this addresses growing concern over the spread of misinformation and fake content in various forms of media. Next is real-time detection capability. To enable the system to detect deepfake content in real time, making it more effective in combating misinformation. Real-time detection ensures the timely prevention of misleading information, which is critical in scenarios like news discrimination or social media monitoring. Third point is awareness. To spread awareness about existing and risk of deepfake content, empowering people to recognize and avoid being misled by manipulated media. Next slide, please. Uh, Next point is literature review. We have reviewed multiple defect detection techniques and datasets, and we come across these challenges like interpretability, making models more understandable and explainable, processing, and generalization. To address these challenges, we have following approaches. We use a GradCam to improve explainability by visualizing where the model focuses during prediction. Next is MTCNN model, which is used to for accurate face detection. Next is optimized inception ResNet V1, chosen for its robustness and adaptability to detect defects effectively. The dataset mentioned like face forensic, Colab DFT, and KEGA data sets act as benchmark for evaluating models. However, the rapid evolution in defect technology necessitates continuous update in these datasets to maintain its relativeness and effectiveness. The next point will be shared by Bharat.
So starting with the methodology, the first step was of data collection. At this stage, we have used ForgeNet dataset, which has over 14 lakh 30,000 of real images and 14 lakh 50,000 of fake images. It is a data labeled dataset, which we have used to train, test, and validate our model. And the pre-processing part, we have used MTCNN convolutional network, which actually is used for detecting the face from the image. So MTCNN forms an image pyramid, resizing the images at multiple scales and then these images pass through 3 layers of the network, PNet, RNet, and ONet, giving us a precise bounding box around the face, and also gives us facial landmarks. Then we have used the inception ResNet model, which combines of inception models and residual connections. So inception modules are the one which help us classify image in two categories, and residual connections solve the problem that if a network is very deep, the information while passing from multiple layers can get lost. So, and the network uh, uh, and it causes a problem that network cannot improve more. So this problem is addressed by the residual connections. Then inception, all the preprocessed images from the MTCNN are passed into inception ResNet as input, and it makes prediction whether the image is a deepfake image or a real image. For the explainability purpose of the model, we have used GradCam, which actually forms a heat map on the image and lets us know which all parts of the image were influential for the model in making decision. Then we have evaluated our model on various matrices like accuracy, precision, and also used the generated heat maps for the insight. Going forward to the results, our model has resulted into 92% of accuracy. The explainability of model has been high due to effective use of GradCam, and the model can perform in varied conditions very efficiently, which makes it robust. So my co-author will now conclude with the presentation.
So our research has developed a system for real-time face authenticity prediction, combining deep learning and explainability techniques to ensure both robustness and transparency. At the core of this system is the inception ResNet model, a powerful neural network architecture that excels in image classification tasks, enhance transparency, and provide insights into decision-making process. We integrated GradCam, a visualization tool that highlights the regions of an image influencing the model's predictions. Next slide, please. Look, future work slide.
Thank you, team, for the presentation. I just wanted to confirm, is Uma Gaurav here? She's not here, right?
No, ma'am, she's not here.
Okay, fine. Ma'am, any questions? Okay, okay. Ma'am, any questions?
Hello, which algorithms are used?
Ma'am, we have used MTCNN and inception ResNet models.
Okay. What is the difference between these models?
So ma'am, MTCNN is the model which actually detects the face from the image, and then it is passed towards the inception ResNet model, which actually classifies whether the image is fake or real.
Okay, you have used a combination of this.
Combination of two
Okay,
models.
fine.
Yes.
Yeah, thank you.
Thank you, ma'am.
Yeah, next.
Thank you, ma'am. Okay, so do we have the presenter of the paper Smart Street Light for Sustainable Cities? Any author or co-author present here? Okay, so we can move to our next presentation. Dhruv Soni,
Yes, ma'am. Am I audible?
you are presenting a paper on the anatomy of lies, machine learning approaches to fake news detection.
Yes.
Yes, sir,
Shall
you
I, shall I
can
start with my screen share?
start sharing your screen, sir.
It's visible, right?
Yes, sir. It's from the, yeah,
It's visible clearly.
the first.
Okay, so good afternoon, everyone. Today I'll be presenting the anatomy of lies machine learning approaches to fake news detection as a part of ninth International Conference on ICT for Competitive Strategies. This study explores how machine learning and deep learning methods can address the critical issue of the fake news that has been spreading throughout these many years. So let's start with the outline of the presentation that speaks of overview, categories of detection models, distribution of various fake news detection methods that is being used, the literature review of the research papers, steps for fake news detection, that how what steps to need to be taken. Next is the performance analysis, then the performance metrics. Next would be practical applications and use cases, and then conclusion, future detection, and the references. So let's start with an overview of the fake news detection. So what is the challenge? Like fake news spreads rapidly on platforms like social media that influences public opinions and causing societal harm. To combat this, robust detection systems are very much essential. So for that, we use machine learning models and deep learning models. Machine learning models like SVM, that is support vector machines, that is used for classification, and new bias that is also used for classification in and those are the traditional models. And deep learning models are the advanced models that includes convolutional neural network, recurrent neural network, and the BERT and ELMO. BERT is basically the is used for language detection, that is ambiguous language for that, and ELMO is also used for language and semantic analysis. So next we would be looking for methods that can how these methods are categorized. So this is basically the flowchart and architectural review of fake news detection techniques. This emphasis on different kinds of techniques that has been divided based on the different kinds of techniques that is used for fake news detection. That includes machine learning techniques, ensemble methods, hybrid models, and traditional models. Next, we would be looking for the distribution of various fake news detection methods. Uh, for example, like machine learning techniques, that is the traditional way that SVM and neo bias have been used very much in proportion. That is machine learning techniques foundational but limited for complex scenarios. That is used 30%. ML techniques are used for most of the majority, but they are limited for complex scenarios. Then we go towards hybrid models. It is very increasingly popular because it combines two types of models: this is machine learning models and the traditional models. That is CNN and SVM. That is the very much popular combination that people are using nowadays for detection of news. So to better understand the techniques, let's review some key contributions from the literature. So this was the literature review that we conducted from research papers. So early studies focused on classical machine learning models like neo bias and logistic regression. Earlier they used to consider neo bias and logistic regression. That was the traditional models. Recent advancement include deep learning techniques like CNN, LSTM, and transformers. That is BERT. As they achieve state of art performance, they have achieved high performance level on the performance metric scale. So nowadays they are preferring for the transform based models. uh, some challenges include the data set biases, computational complexity, and the evolving nature of misinformation, as some of the information are very fake, but they pretend to be the true information. So that becomes very ambiguous to detect. So we use traditional advanced models for that. Now let's move on to the steps involved in fake news detection. So these are just the general steps that includes first the feature extraction. That is, we use TF-IDF, that is term frequency and inverse document frequency, word embeddings in sentiment analysis, that is feature extracting the different kinds of features available in the data. Second we do is model training. We use CNN for local features, LSTM for sequential data. And next step would be the evaluation, that is validating using precision recall and F1 score, that is the performance metrics. Now we'll explore how this system performs in practice. Okay, so this is a performance analysis. By looking towards this analysis, we find that traditional machine learning models like support vector machines and nearby achieved around 85% accuracy. These methods are efficient and resource friendly, but they struggle to handle complex data language patterns. Like, for example, we consider Hindi or Gujarati or any regional language in example. I find it ambiguous to understand. So for that, we use traditional language, advanced language, that is MBERT, that is multilingual bidirectional encoder transformer language. As I said, the advanced deep learning models such as
Dear
CNN and
presenter, you have 2 minutes left.
okay, so yes. So now let's examine the performance metrics, how they perform on the precision recall and accuracy. So as we said, BERT excels in all precision, all the performance metrics levels as it uh, minimizes the false positive for the precision, accurately identifying fake news instances for the recall, and F1 consistently outperforms other models. Uh, but reaches 95% higher than hybrid models. Even though it is an advanced model, it reaches higher than the hybrid model, combination of traditional and machine learning models. So next we will be looking for the practical applications. That is, fake news detection has several real-world applications that include social media monitoring, election integrity, media and journalism. Media and journalism is the most widely source of spreading of fake news. So we need to identify those data very accurately. Uh, Now we will be looking for the conclusion and the future direction. In conclusion, advanced machine learning and deep learning models have significantly improved fake news detection. However, challenges persist, including dataset biases, evolving misinformation techniques, and high computational demands. Those are the few challenges. For future research, research should focus on developing adaptive models, uh, dataset diversity, incorporating multi-model analysis, and leveraging real-time fact-checking systems. Uh, so addressing these areas will enable the development of robust, scalable systems to combat fake news uh, effectively. So thank you for your attention. And these are the references. And thank you for your attention. I would like to conclude.
Thank you, Dhruv. Thank you for your presentation. Any questions, ma'am?
Yeah. Um, Dhruv,
Yes,
what
ma'am.
is the advantage of this SVM algorithm over naive bias?
Okay. What is SVM? SVM uses a hyperplane. So for uh, classifying different kinds of data. So SVM uses hyperplane for classifying different kinds of data, and new bias using the mathematical computation. So this is a big difference. That is a graphical difference.
Ma'am? Hello, Dhruv?
Hello.
Yes.
Hello.
Yes. Yes.
What kind of accuracy do you get with SVM?
Accuracy is the kind of we get. Accuracy is that is how false positive or negative is the kind of data. So a hyperplane divides different kinds of data and then classify which are false positive and which are false negative with SVM.
No, have you done any study on the accuracy of detection of fake
Uh,
news?
uh, okay, so
How
actually
to
our
do?
task was to create a review paper.
Oh, yeah.
So focus on various machine learning approaches.
So in
That
the
was
review paper also they may be mentioning, no? Have you made a study on that?
yes. So what we have identified from the review paper, that is the objective, the methods they have used, and the findings of different kinds of paper. Then we have made the graphical analysis.
Okay, specific algorithms you have not studied, I think, no?
Mhm.
Okay, thank you.
Thank you.
Yeah.
Thank you. Thank you, ma'am. Thank you,
Yeah.
Dhruv. Just a minute.
I think one paper is not present, creative
Yeah, they are
destruction.
not here. There are
They're
two
not.
papers.
Two papers, yeah.
Is there anyone from the paper Smart Street Light for Sustainable Cities? Anyone from here for this paper? Okay. Anyone for creative destruction of risk in financial institutions through technology? Fine then. Okay. We have come to the closing remarks now. I sincerely thank our authors for their excellent contribution and presentation in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 9th version and the previous 8 versions of the conference. I hope to see you in the 10th version as well, which is in 2025. All the presenters would be getting their certificates through email within 2 working days. Further, all the papers have been forwarded to the Springer board and the publication will be live within 6 months. Kindly cooperate with the team of ICTCS 2024. I also thank our session chair, ma'am. Thank you so much for chairing the session. It was great to have you here, ma'am.
Thank you,
Yes.
Deepika. It was a very nice session. I'm sure all the participants also had a good learning experience.
Yes, yes. Thank you so much for your valuable presence. This is a token of appreciation from the JKRF team and the team of ICTCS, ma'am. Thank you so much.
Thank you. I wish you all the best.
Thank you. I request all the participants to turn on their cameras for a quick snapshot of the digital conference, please. All right. Thank you so much. Thank you, everyone. Thank you. Stay safe. Take care. Thank you.
Bye bye.